Okay, so I'll start the session for today. So as I mentioned earlier, this is one of the papers that you can take many informative papers. Last time it was 2013 and this time it will be 2015 that you can take many information out of paper. There will be a lot of testing of the knowledge that you have here. Okay, so we will move on without making much time here. So typical question again. You have given several compounds and you have to decide based on which compound is based on the factor, based on the property. Okay, so statement 1 says both ionic and covalent bonds. So which one has ionic and covalent bonds? That is what they are asking here. So XCF2 more or less it's covalent, and here NO3 minus and SF5 minus both are covalent in nature. The negative charge is because of additional electron that is present in the structure, Lewis structure. So these two are covalent, and SO3 is, it is automatically covalent, and HF is again ionic. So the possible answer for this is Na2SO4, because sulfate, you should know there is this covalent bond between sulfur and oxygen. This is SO4 2 minus. Structure, either you can put this O minus here and draw this so double bond here as well. And then you have Na plus, which will be our counter ion. In fact, two of them. So there will be ionic interaction. Normally we don't say these as ionic bonds, okay, because there are no bonds there. Okay, typically this is called as ionic interactions. So Na2SO4 is here. And what is isoelectronic with BF3? So first of all, identify what is isoelectronic. So isoelectronic means similar number of electrons in the entire structure. So boron, it has 3, and fluorine, it has the valence electrons like 7. 7 into 3 is 21. So it has 24 electrons in the structure, right? However, so when you find which one is isoelectronic, you will see nitrogen, which has 5 electrons, and oxygen, which has 16 to 3, 18 electrons. So automatically here there are 23, and due to the negative charge there will be 21. Okay, so you can go in that way as well. Then square pyramidal means 4 bond pairs basically, and 2 lone pairs. So which one has 4 bond pairs and 2 lone pairs? So sulfur, you have this is not square planar, this is a square pyramidal, so it should be like 5 and 1. So here's SF5 sulfur, you have normally 5 bonds with fluorine because there are 5 fluorine, and in the valence shell there are 6 electrons, so there should be 1 additional, and due to the negative charge there will be another. So this is the lone pair and these are the 5 bonds, so that is why this is square pyramidal. Okay, and has an equal number of bonding and non-bonding electrons in this most stable structure. So this is a little bit tricky because if you think about SO3, so there is a double bond like this, another one, and another one. Okay, so there are 4 non-bonding electrons in oxygen, in each oxygen. Okay, so 4, 8, 12. So there are 12 non-bonding electrons in oxygen, valence electrons. In sulfur, you see all are bonded here, 2, 6, 8. In fact, 2 here, 4 makes 4. So 4, 8, 12. So basically, around sulfur, there are 12 bonding electrons. And around oxygen, there are 12 non-bonding electrons. So that is why this is called bonding and non-bonding electrons. Okay. And has a sigma bond as a result of the overlap between 1s atomic orbital and 2p atomic orbital. So you can imagine based on these elements, okay, 1s either it should be sodium or either it should be hydrogen. So sodium sulfate is already taken, and so therefore this is HF. And finally contains a bond angle of 180 degrees. So it should be like linear molecule. The only possible linear molecules here is HF or XEF2. So when you consider about XEF2, so xenon is in the noble gas period, so it should have like F and 3 lone pairs. That's the idea, right? So this lone pair repulsion makes this xenon fluoride a linear molecule. Normally, when you have 2 bonds, no lone pair, it becomes linear in geometrical shape, and 2 bonds, 1 lone pair, or either 2 lone pair, it makes you a bent or angular. But when you have 2 bonds and 3 lone pairs, again it makes a repulsion as to make it a linear molecule. Okay, so that is important to understand. So this is the typical discussion of for this type of a question. Okay, their electronegativities are greater than 2. So when you consider about the Linus Pauling case here, their electronegativity is greater than 2. We have here this set of elements. Okay, carbon, nitrogen, oxygen, fluorine from this group, and phosphorus and sulfur from this one, because silicon is 1.8. So it is not actually necessary to know these values, but just try to know for 1, 2, and third period. That is fine, because it is easy. This goes way like this. Hydrogen is 2.1, so lithium is 1, 1.5, 2, 2.5, 3, 3.54. And then you can subtract 0.1 here, so this will be 0.9, and add 3 up to 0.9 means you add 1.2, and this will be 1.5 because there is 0.4 different. Then there is 1.8, another 0.3, then 0.3, another 2.1, and then it becomes 0.4, 2.5, 3, and 0.8 and 1.0. So try to remember those electronegativity values. It will be very helpful for you. Okay. So based on this information, it says QRT, they are greater than 2 electronegativity values, and Q and R belongs to the second period. So Q and R belongs to second period. So Q as well as belongs to second period. So what are the elements that can be possibly present in the second period? That is carbon, nitrogen, and oxygen, and fluorine. So these are the elements with values greater than 2. And they say T belongs to the third period. So third period, we have phosphorus and sulfur, even chlorine as well. They're possibly present. So this is in the second period. This is T in the third period, right? So they also have given us the skeletal diagram. So we have 3 oxygens here. So this one of the oxygen should have negatively charged because it says it should have negative, and we can decide based on that what is Q, what is R, and what is T. Okay, so let's start with Q and R. So Q and R, this is carbon, nitrogen, oxygen, or fluorine, it can be. Now think about the factor. If Q is carbon, think about that. If Q is carbon, what it will happen here? This is the skeleton. And if R is nitrogen, what it can happen? So if Q is carbon and if R is nitrogen, there will be like a hydrogen like this, and there will be T, which can be essentially from phosphorus, sulfur, and chlorine. But it says there are no charges here in the other atoms. The only charge that is present here is in oxygen. So I think this can be here, or maybe it can be somewhere else. But to be somewhere else, one of these elements should be oxygen, because it shows acidic character. So the easiest possible way to think is there could be a negative charge here. So Q, if I take this as carbon, R nitrogen, and T, it can be either phosphorus, sulfur, or chlorine. But to have a negative charge here and to have no charge here, there should be like a double bond with oxygen, this one with T, and another double bond with oxygen, and only this one should have a negative charge, and there is an additional bond. So you see the valence electron, 1, 2, 3, 4, 5, 6. So there should be 6 valent electron, which makes its charge neutral at this case. So from this, the only possible thing that you can add here is sulfur. Why? Because if you add phosphorus here, T, there will be 6 electrons, mean there will be a negative charge. Chlorine, so again it's problem, right? So it will be more negative. So the only possible element for T is sulfur, because it will have 6 valent electron, and there will be 6 covalent bonds here, and there will be no charge in sulfur. Okay, so the only possible answer for T is sulfur. However, when you consider about T, then if T is sulfur here, so in the Lewis structure there can be double bond here and another double bond here, and there will be a negatively charged oxygen here. And if you think now, this is nitrogen and this is carbon. Okay, so nitrogen basically it has 3 bonds here and a valence electron, so there are 5 valence electrons, so I have put 5 here, and there is no charge, so no problem. So then carbon, there is hydrogen here, but when you think about this carbon right now, there is a problem, because according to this structure, carbon should have another valence electron like this, but you see the octet is not completed here, because carbon has 4 electrons. Now in this structure there is no charge, no problem, but you know when we draw the Lewis structure there should be 2, 4, and there is only 6 electrons, so this is electron deficient now. The possible way to make it electron completing the octet is to form a double bond like this. So there will be a hydrogen like this, and there will be a lone pair like this. So now 2, 4, 6, 8, and nitrogen will have hydrogen like this. And now you see there is a positive charge here in the nitrogen. So this cannot be our answer for Q and R. Q and R cannot be carbon and nitrogen. Okay. So likewise, you can check another element, like maybe first you can interchange this. For an example, let's say we interchange this as nitrogen and carbon. So you don't have much options, you have only these options. And make sure when you draw the Lewis structure, there is no charge. That is the important thing. Okay, so when I draw this as nitrogen and carbon here, so I see nitrogen, there should be hydrogen here that is given in the structure, and carbon, there is hydrogen here. So nitrogen, there should be like 1, 2, 3, 4, and if I take one electron from here and one electron from here, for carbon I can make a double bond like this. So there will be my lone pair here, and there is now sulfur here, which makes our entire structure. And here, when you think about this structure, here the octet is completed, and here also the octet is completed, right? So in fact, 1, 2, 3, 4, 5, no charge. 1, 2, 3, 4, no charge. So sulfur also no charge. So this structure is possible, and this structure is possible because there is no charge. And in the same way, if you check for oxygen and nitrogen, why I get nitrogen? Because I see 3 bonds here to complete its octet. So this is sulfur, there is a lone pair like this, and there can be oxygen with 2 lone pairs like this. Okay, and there is this nitrogen here, oxygen, nitrogen, and this is sulfur, and there is this double bond. Okay, this is the structures that are possible. So what is the importance of this question? This question gives you several ideas. That is the important thing that you need to take. There are 2 possible structures that can be drawn from the information given. Okay, but in both cases, T is always same. T is always sulfur, because it should not have charge if you have a charge on oxygen atom. And if you think here, when you draw this structure, the negative charge is here, automatically this would have 2 negative charges. So there will be no possibility to draw a Lewis structure like this. Okay, so that is one of the things that you need to understand, right? And the other thing is you have oxygen OH here, and the octet is completed here, and the octet is completed as here. And then try carbon and oxygen. You will see there is a positive charge in oxygen when you draw the double bond, so it cannot be accepted. So there are 2 structures that can be accepted here. So one, it can be Q can be nitrogen and carbon in one case. So there will be NCS here, NCS bonding. And in another case, this will be like oxygen, nitrogen, and sulfur. So there are 2 possible structures that can be present for this particular question. Okay, so did you get the idea? That is the important thing, why there is 2 possible structures. And you can try the other combination. So I tried like carbon and nitrogen and the reverse, and then nitrogen and oxygen. You can try the reverse and see. So more or less, when you get one of these structures, it is enough. You don't need to draw 2 both structures. Okay, you just need to find one. That is important. Okay, so did you get the idea? That is important here. Okay, so seems like no question, so I will move forward. So our structure, so when you identify the elements Q, R, and T based on the properties that they have given and based on the information in the description, so it becomes our Q and RT, either nitrogen, carbon, or sulfur, or oxygen or nitrogen or sulfur. So then you have the Lewis structure. You can draw the Lewis structure based on our normal typical method, and then you try to draw the resonance. Okay, And the second statement, it says draw 6 resonance structures for this anion. Okay, so this is directly from the evaluation, but there are some wrong that they have done here. So because there should be like a single bond here and a negative charge here, could be a printing mistake. So this structure, you can see there are how many resonance structures that you can draw here, because this structure is little bit complex, and you have lone electrons in oxygen, lone electrons in nitrogen, lone electrons in here in 3 oxygens. So you can change the position of this electron, you can transfer this position of the electrons, so you can draw many Lewis structures as this. Okay, so how we obtain this one from this one? So you push these 2 electrons here, forming the double bond here, and this forming the single bond. So then you will get this one. Okay, and then you push these electrons here and you push the electrons towards this oxygen and you get this one. Likewise, you can change the position of this electron and draw all the resonance structures that is possible. That is the normal way. Otherwise, you can just think, okay, so there is 2 double bonds here and 1 negative charge. So I can change this negative charge on this one or this one. So there will be 3 structures, 1, 2, and 3. Okay, and the other structure, what I can do here is I can change the position of nitrogen. So I can make a bond between nitrogen and sulfur and make this oxygen a negative charge. So there will be a bond here like this, nitrogen and sulfur, there will be a double bond, and this negative charge is forming here from the double bond. Okay, and I can form this negative charge 1, 2, 3. So there will be another 3. So you can draw 6 structures. That is done. Okay, so if you understand, I will show the board what I'm telling, because this becomes straightforward because you have the structure now. So for an example, if we take this as oxygen so we have sulfur like this with a double bond, and let's make it nitrogen. So there is in fact a hydrogen on the top of nitrogen. Okay, so this is the normal way. We have a lone pair here, and we have 2 here and 3 here. That gives this a negatively charged. So this is one of the structures that you can draw. Okay, so I hope you can see the screen, right? So they are asked 6 structures, so it will be straightforward. So you give negative charge here. In the second step, you can give negative charge here, and in the third step, you can give negative charge here. So there will be 3 structures like this. 2, and I have given negative charge here, so the other one will have negative charge here. Okay, so if you want to know how this is formed here, in the first place, to form this one, so I can make this as this one, to form this, and to form this, there is negative charge here, so this will be bonded again like this, and this will be taken like this to form this one. Okay, so those 2 are 3 structures, and the other one is nitrogen. So there can be a bond between nitrogen and sulfur, and one of these double bonded oxygen can be made to a negatively charged species. So there will be another 2 structures based on that: double bond, negative charge, double bond, negative charge. Anyway, the idea is there can be many structures that you can do even using oxygen and nitrogen bonding, but you have to draw only 6. That is important to identify first. So draw 6, so that's fine. Don't try to do and see whether you can draw many structures. So this is not a point where you try to study how to draw the Lewis structures. Okay, at this point you should be very familiarized with it. Okay, you cannot spend much time on it. So this is many structures that you can draw. Just find 6. That's it. Okay. Right. So moving on. So we have a Lewis structure. So then the same typical question every time that they ask. So you can mention the electron pair geometry. So you have the Lewis structure here. Again, I will draw the Lewis structure here. So we have oxygen here. For an example, we will take that structure. And then we have nitrogen, the lone pair, and hydrogen. And then this is bonded to sulfur, which has a double bonded oxygen in both sides, and there will be a negative charge here. And there are 2 lone pairs here in oxygen, okay, because it has 6 valence electrons. So what is our Q? So Q is here oxygen. So electron pair geometry 1, 2, 3, 4. So we have 4 repulsion units. So this will be tetrahedral. And for R 1, 2, 3 again, this will be tetrahedral. And for T 1, 2, 3, 4 again tetrahedral. Okay, so electron pair geometry, we go with the total repulsion units. And shape, this is this should be 2 bonds and 2 lone pairs. So this should be bent or angular. So 3 bonds, 1 lone pair means pyramidal, and there are 4 bonds here, so no lone pairs. So this should be tetrahedral. Okay. Hybridization, again, all the repulsion units, sp3, 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 no change. And bond angle, so since this is angular, so it should be less than 120 and the greater than 109. So it will be like in between the bonds. So in fact, the correct bonding, so if I want to give you the correct bonding of this setup, so it is around 103 to 105. So that is what they have expected. Okay, so remember, okay, 103 to 105. This would be necessarily need to understand. Okay, so this is around 103 to 105. That is what they have expected about the bending, right? And for nitrogen, it's pyramidal. So you can imagine this is not trigonal plane. So not 120 again. It will little bit push the bonding between these angles because of the lone pair, right? So this is a pyramidal structure, and this will push the bonding little bit in 3D, okay, both ways. So this will be around 106 to 108, and this is since tetrahedral, you know, it will be around 109.5 if the bonds are same, but here there are double and single bonds, so you can give this as around 108 to 110 because it can be changed here. Then again, very straightforward. So you know the hybridization here. So you just need to find what are the hybridization here as well. So Q and R. So this is Q and R. So sp3 and sp3. R and T, again sp3 and sp3. And T is sp3 here, and O minus. This could be either there are lone electrons. So this could be either sp3. That is one answer that is possible, or either 2p. Okay, these two can be taken because oxygen is terminal here. Okay, so these things are very straightforward that we have discussed again and again. So the next question is important. So state what information is directly provided by the Lewis structure. So you can imagine what information is provided from this Lewis structure. What are the informations? So bonding is provided, so that you cannot tell this is bonding because that is why it is a Lewis structure. So try to identify. It shows valence electrons, right? That is one. And additionally, it shows charge where oxygen has a negative charge and that one has a positive charge. So these two are directly shown here. Okay, you can see the valence electron, number of valence electrons here in a Lewis structure, and charge directly. So all these things are given directly. The state 1 information is not directly provided. So not directly means all these are not directly provided. For an example, electron pair geometry is you can find, but it is not directly provided to you. And even shape and even hybridization. So you can write one of these here because these are not directly provided. But if there is charge, you cannot write because those are shown directly. Okay. So try to understand the difference. So this slide is just to show there can be an alternative answer as well, where we found one is nitrogen, the other one is carbon. So if you take one is nitrogen, the other one is carbon, again, you can draw several restructures. The only thing is you need to just know to draw how to draw, and only 3 of them. Okay. So these are the answers for that particular part. When you take nitrogen, carbon, and sulfur, so this will be the restructure. And you can see QRT, it is sp2, sp3, and sp3 based on the hybridization. Then you can imagine the shape. So this is angular. There are 3 bonds here, and R is this carbon. So 1, 2, 3, 3 bond and a lone pair. So this should be pyramidal, not trigonal planar. And then 1, 2, 3, 4. So this is tetrahedral. That is okay. And then electron pair geometry 1, 2, 3, trigonal planar, 1, 2, 3, 4, tetrahedral, 1, 2, 3, 4, tetrahedral. So this should be changed here. Printing mistake might be. And then you can know the hybridization and all those things. So finally, we are here. We should focus on this one. So this is the normal structure. First, they will give some compounds, and based on the properties, you have to categorize them. Then it is a Lewis structure question. And then finally, another few small part where you again need to decide based on the periodicity. So the decreasing order of electronegativity of NH3 and NO2F and NO4 3- is this order. So you need to find whether this is true or false, and then you need to explain the reason. That is important. Okay. So tell me whether this is true or not. What do you think? Quickly. So when you think about the charge or the oxidation, you can go with charge or the oxidation, as I have told you before, because this type of question we have seen before here in the first para, right? In the first question, part A. So they have now asked in the part C. So this is true. Why? Because if you think about the oxidation state, you can see this will be -3 and this will be +5 for nitrogen, and this will be also +5 when you draw the structure, you can see. Okay. However, when you think about NO2F and NO4 3-, when the structure is considered, you will be see there is more S character here in NO2F. So that is a general way. You have to mention about the oxidation state, and then mention about the S character, and then tell when the S character is increasing, the electronegativity is increasing. Therefore, this order is correct. So those 4 points are very important, because otherwise you will lose mark. If you just mention oxidation state and then the electronegativity is increased, there is a problem, because there are 2 compounds with the oxidation state is same. Okay. So you have to mention about the S character here for NO2F S character. Okay. Don't forget to mention that when you think about this character. How do you consider this character? After you just try to do the structure very quickly and see the hybridization. So this will be like sp2 and NO4 3-, this will be like sp3. So when you have sp2, there is more S character. And in case if you have sp, there is more S character. You can see 50% S character, then how many, 33 something S character and 25 S character. So when this character also increasing, then the electronegativity is also increasing. Okay. And the second one is increasing order of melting points of lithium halide. So this is again typical. You know how to explain this. First thing, you need to find whether this is true or false. So what do you think? So we will describe and then see what is true or false. So first thing that you have to mention here, cation is same. And anion, you have to mention about its polarizability. You know melting point and boiling points, you can determine it using the covalency or ionic nature. When it is more ionic, melting and boiling points are very high. When it is more covalent, it is less. Okay. So when you think about these compounds, lithium, 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 so the cation is same. And then you can mention about the anion size. So fluorine, chlorine, bromine, iodine. So the size is increasing. When the size is increasing for a negatively charged species like fluorine, chlorine, bromine, and iodine, when the size is increasing, polarizability also increasing. Okay, so there will be highest polarizability for I minus. So if there is higher polarizability, the compound is more covalent. And when the compound is more covalent, the melting point and boiling point are lower. So according to that, lithium fluoride, the polarizability is very minimum. Okay, so this will have the highest ionic nature. Therefore, this statement is wrong. Why? This should have the highest melting point. Okay, so you need to write cation is same, and the size of the anion increases as F minus is smaller than Cl minus, Br minus is greater than Cl minus, I minus is greater than. Then you need to write the polarizability also increases in this way. Therefore, the ionic nature is in the reverse order. So therefore, melting point and boiling point should be the other way around. You can just put the inequality sign to the other side. Okay, so this is wrong. So this is a very good comprehensive question, especially the this one, the Lewis structure question, because this was very tricky between even the students, because when the students write, they one set of students, they have this and the others have this, and when they discuss about the answers, they got confused. In fact, both of them are correct. Why? Here you can identify their two possible answers. This is the first time that we see this type of things, okay, in 2015. So this is why this becomes very informative.